Fine. Let's start. Number 10. The microwave oven beacon. Picture a giant dish in the Australian outback, 64 meters of steel tilted up at the Milky Way, and every so often it catches a strange little burst of radio energy. Short, sharp, smeared out in a way that looks exactly like the signals we get from the far side of the universe. The astronomers at Parkes had a name for these. They called them perytons, after a mythical winged creature that casts the shadow of a human instead of its own. Fitting, because for years these bursts were shadows. Something was there, and nobody could say what. Here's why that mattered. Around the same time, Parkes was famous for detecting fast radio bursts, genuine millisecond flashes from billions of light years away that we still don't fully understand. And the perytons looked just close enough to the real thing to poison the well. Were the cosmic bursts real, or were we fooling ourselves with our own noise? Nobody could cleanly tell. So in 2015, a researcher named Emily Petroff decided to actually hunt the thing down. New interference monitor, careful logging, and the pattern that fell out was almost too stupid to publish. The perytons showed up mostly around lunchtime. They clustered on weekdays, and they only appeared when the telescope happened to be pointed at a particular building on site. The culprit was the staff kitchen, specifically the microwave ovens. It turns out that if you're impatient, if you yank the door open before the timer hits 0, the magnetron inside doesn't shut down cleanly. For a fraction of a second, it leaks a burst of radiation near 1.4 gigahertz, right into the band the telescope was listening on. One of the most sensitive instruments ever built, briefly blinded by somebody reheating their coffee. And the reason this is the perfect place to start is that it's the whole channel in one story. A signal from the sky that looks impossibly alien. A serious, patient investigation. And an answer so mundane it's almost insulting. But notice what the scientists did. They didn't announce first contact. They installed better equipment and caught the snack break red-handed. So keep that in mind for everything that follows. These are the ones that survived that kind of scrutiny. Some got explained, some didn't. But every single one made a serious person stop and ask the question out loud. Somewhere out there, a microwave door is still slamming. And for a few years, it was the most mysterious object in the sky. Number 9. The supercivilization that was a black hole. Go back to the 1960s. The space race is on. The sky is being mapped in radio for the first time, and out of that new map comes an object with the unglamorous name CTA 102. Just a powerful smudge of radio waves, cataloged by Caltech. Nothing to look at. Until a young Soviet astronomer named Nikolai Kardashev looked at it and said something that made the whole world sit up. Kardashev had been thinking about what an advanced civilization would actually look like from a distance. He'd sketched out a scale, the one that still carries his name, ranking civilizations by how much energy they can harness. A Type 2 harnesses a whole star, a Type 3, a whole galaxy, and he suggested that a mysterious radio source like CTA 102 might not be a natural object at all. It might be one of them. A beacon. Then, in 1965, his colleague Gennady Sholomitsky found something that seemed to seal it. The object's radio output was varying, changing over time. And a signal that changes is a signal that could carry information. On the 12th of April, 1965, the Soviet news agency announced it to the world. CTA 102, they said, was the beacon of a supercivilization. It was a sensation. Newspapers ran with it. For a brief window, the official position of a major scientific establishment was that we might have found somebody. And you can feel why. Everything lined up. A strange source. A variable signal. A respected theorist saying the words out loud. But here's the thing. When the big telescopes at Palomar turned to look, they didn't find a message. They found a quasar, one of those blindingly bright cores where a supermassive black hole is devouring matter and firing out radiation across the entire electromagnetic spectrum. The variability that looked so deliberate, so engineered, that's just what a feeding black hole does. It flickers as it eats. And that's the pattern you're going to see again and again in this list. The thing that screams artificial, the rhythm, the pulse, the change over time, keeps turning out to be nature operating at a scale we hadn't imagined yet. We went looking for a civilization powerful enough to light a beacon across the cosmos. What we found was a black hole, the mass of 1 billion suns, doing something far more violent than any civilization ever could. The aliens would have been extraordinary. The truth was worse. Number 8. The signal that leaked to the press. There's a star in the constellation Hercules called HD 1644595. It's about 95 light years away, and it's almost unsettlingly ordinary. Roughly the size of our sun. Roughly the temperature of our sun. It even has at least one planet. If you were writing a list of places to point a telescope and hope, this quiet little sun-like star would be near the top. On the 15th of May, 2015, a Russian radio telescope called Rayton 600 caught a strong spike of radio energy coming from that direction. A clean, powerful burst. And then, for over a year, almost nobody outside a small circle knew about it. Then, in late August of 2016, it leaked. Word got out that there was going to be a presentation about a candidate signal from a sun-like star, and the internet did what the internet does. Within days, it was everywhere. A strong signal. A sun's twin. 95 light years away. The headlines practically wrote themselves, and for about a week, the world let itself wonder. The SETI Institute swung its own instruments over to take a look. The Allen Telescope Array in California stared at HD 164595. Other groups joined in. Everyone wanted to catch it again. Nobody did. And when the Rayton 600 team went back through their own data, the astronomer Yulia Sotnikova put out a statement that quietly ended the party. The signal, she wrote, had a most probable terrestrial origin. Translation: it was us, almost certainly a satellite, quite possibly a piece of Soviet-era military hardware, drifting through the telescope's field of view at exactly the wrong moment. But here's the detail that sticks with me. Suppose it had been real. Suppose that signal really had come from a transmitter circling that star. For it to reach us that strong, blasting out in all directions across 95 light years, the civilization behind it would need to command the energy of an entire star. A Kardashev Type 2, harnessing the full output of their sun just to say hello. The false alarm was a satellite, but the thing the false alarm implied was almost incomprehensibly enormous. That's the strange gift of these near misses. Even when the answer is boring, the question forces you to do the math on what a real detection would actually mean. And the math is staggering every single time. A blip on a Russian antenna. And for 1 week, 100 million people looked up at Hercules and let themselves believe. Number 7. The weird signal from next door. Ross 128 is about as close as neighbors get. A small, dim red dwarf star just 11 light years away. So faint you can't see it without a telescope. In 2017, a team led by the astronomer Abel Mendez, running the giant Arecibo dish in Puerto Rico, was doing a survey of nearby red dwarfs. Routine work. Point at a star, record the radio, move on. Then Ross 128 did something strange. For about 10 minutes, the telescope picked up a series of broadband pulses, almost periodic, that didn't look like anything the team expected. They checked the stars observed just before and just after. Nothing. Whatever this was, it belonged to Ross 128 and Ross 128 alone. Mendes's group started calling it, informally, the weird signal. That was the actual working name, the weird signal. Now, to their enormous credit, they did not run to the cameras. They laid out the possibilities, like scientists are supposed to. Maybe it was a flare from the star itself. Red dwarfs are famously violent little things. Maybe it was another object in the same patch of sky. Or maybe it was a satellite in high orbit, passing through. And because the reputational stakes are brutal in this field, they called in the heavy hitters. Breakthrough Listen. The SETI Institute. Some of the best signal hunters alive turned their attention to a star 11, light years away. The verdict came within weeks, and it was almost poetic. The best explanation was geostationary satellites. Ross 128 happens to sit close to the celestial equator, and that's exactly the strip of sky where we park our communication satellites, thousands of them, in a ring high above the planet. The weird signal wasn't the star talking. It was our own machines, glinting radio back down at the very dish we were using to listen for someone else. And here's the thing that lingers. We have spent decades listening to the sky for a message, but we've also been steadily filling that same sky with our own chatter. Every satellite, every transmitter, every burst of data we fling into orbit crowds the exact frequencies we strain to hear across. The nightmare scenario for a radio astronomer isn't silence. It's that the cosmos could be whispering, and we've gotten too loud to hear it. The call, in the end, was coming from inside the house. And somewhere in that answer is a quiet warning about what we're doing to our own ability to ever pick up the phone. Number 6. The best hit from an empty sky. In the early 2000s, millions of people volunteered a piece of their home computer to a project called SETI at Home. The idea was beautiful in its simplicity. Radio telescopes generate more data than any team can sift through, so the data got chopped into tiny packets and mailed out to ordinary machines all over the world. Your desktop would chew through a slice of the sky while you slept, hunting for a pattern that shouldn't be there. It was the largest search for alien intelligence ever run, and it was powered by screensavers. Out of all that noise, out of billions of packets, one candidate rose to the top. It had a clumsy catalog name, SHGB 02 plus 14A. It was detected using the Arecibo telescope, picked out by volunteers in Germany and in Wisconsin, and it was announced in 2004 as the most intriguing thing the project had ever found. It had been seen not once, but 3 times. And it had a couple of features that made the back of your neck prickle. It sat right around 1420 megahertz, the frequency of neutral hydrogen. That band has a nickname among SETI researchers. They call it the water hole, and the theory is that it's a natural meeting frequency, a quiet channel any curious civilization might logically choose to broadcast on. The signal was sitting in exactly the place we'd told ourselves to look. But the strangest part wasn't the frequency. It was the address. When they traced the direction it came from, it pointed at a patch of sky between the constellations Pisces and Aries, where there are no known stars for 1,000 light years. An empty spot, a blank, a signal arriving 3 times from a place with apparently nothing in it to send one. Now the honest ending. SETI at Home themselves pumped the brakes hard. The signal had a peculiar frequency drift that behaved in ways more consistent with an artifact than an alien broadcast. It could be random chance. It could be a quirk of the electronics. It was never confirmed, and it was never seen again in a way that settled anything. But it also was never fully explained. And there's something haunting about that particular kind of unsolved. Not a scary signal from a menacing source. A faint, tidy little pulse that came 3 times from an empty corner of the sky. Got everyone's attention, and then went quiet forever. The best hit we ever got. From nowhere at all. Number 5. the first time we heard a planet. Everything so far has been a signal from a star, or an instrument, or an empty patch of sky. Now the scale changes. Because in 2020, a team led by an astronomer named Jake Turner did something we had never done before. They may have heard a single planet. The planet is called Tau Boötis b. It's a hot Jupiter, a giant gas world whipping around close to its star, about 51 light years away. Using a sprawling European radio array called LOFAR, a network of thousands of simple antennas spread across the continent, Turner's team went looking for something incredibly faint. Not a message, a hum, the natural radio glow that a planet's magnetic field gives off as it interacts with its star's wind. We know planets do this because we can hear it in our own backyard. Jupiter is a roaring radio source. Its magnetic field is so powerful that the radio storms it generates can, at certain frequencies, outshine the sun. So the question was simple and audacious. Could we detect that same glow from a giant planet orbiting another star entirely? They searched 3 systems. 2 came up silent. But Tau Boötis showed a faint, circularly polarized burst of low-frequency radio, right where the physics predicted a planet's magnetic field should sing. Tentative, careful, wrapped in every caveat you can imagine. But possibly, just possibly, the first radio emission ever captured from a world beyond our solar system. And here's why this matters more than it might sound. A planet's magnetic field isn't just trivia. It's a shield. Here on Earth, our magnetic field is part of what deflects the solar wind and keeps our atmosphere from being stripped away into space. It's one of the quiet reasons this planet is alive. So if we can start hearing the magnetic fields of distant worlds, we're not just cataloging them. We're beginning to check which ones have the armor that life might need. I have to be straight with you. A follow-up campaign with a different telescope didn't redetect the burst, so this one still sits in the maybe column. It hasn't been nailed down. But even the attempt is a milestone. For all of human history, other planets have been points of light. Silent, untouchable. And then, one night, across 51 light years of nothing, one of them may have made a sound. Not a hello. Just a hum. The private magnetic voice of a world that has no idea we exist. Number 4. The clock that shouldn't tick. Most of the readings on this list got explained. A microwave, a satellite, a black hole. This one did not. This one is still open, and the more you understand it, the less comfortable it gets. Its name is GPMJ 1839-10, and it lives about 15,000 light-years away toward the constellation Scutum. In 2023, a team led by the astronomer Natasha Hurley-Walker announced that it does something that, according to our physics, it simply should not be able to do. Every 22 minutes or so, it flares. A bright, powerful, highly organized burst of radio energy, lasting anywhere from 30 seconds to 5 minutes. Then it goes quiet. Then, right on schedule, it does it again. To understand why that's a problem, you need to know about the death line. Objects like neutron stars can beam out radio pulses because they spin fast and carry monstrous magnetic fields. But as they age, they slow down. And below a certain speed, the theory is clear. The engine cuts out. There isn't enough voltage across the star to generate the radio emission anymore. It crosses the death line, and it goes dark. Forever. A 22-minute rotation is agonizingly, impossibly slow for this kind of object. GPMJ 1839 is sitting deep on the wrong side of the death line, in the graveyard, and it is still screaming. Loudly. Cleanly. On a schedule you could set your watch by. And then the researchers did the thing that turns a curiosity into something genuinely unsettling. They went back into the archives. Old data. Forgotten observations. And they found this object pulsing in records going back at least 33 years, to 1988. It has been keeping perfect time since before most of the people studying it had picked up a telescope. Decade after decade. Tick, tick, tick. From a thing that, by every rule we have, should have fallen silent long ago. Nobody is saying it's artificial. Let me be clear about that. The leading idea is that it's some exotic kind of magnetar, a class of stellar corpse we don't fully understand, doing something our models haven't caught up with. It is almost certainly nature. But sit with what that means. 15,000 light years away, in a region of physics we thought was dead space, something has been pulsing with machine-like regularity for over 3 decades, and our best scientists can only shrug and say, we don't have a model for that yet. It's not aliens. It might be worse. It might be a rule of the universe we haven't learned. Number 3. 7 stars wearing something. If a civilization ever got truly, unfathomably advanced, physicists have a guess about what they'd eventually need. Energy. More energy than a planet could ever provide. And the ultimate source, sitting right there in every solar system, is the star itself. So the idea, floated decades ago by the physicist Freeman Dyson, is that a sufficiently advanced species might build a vast swarm of structures around their sun to capture its output. A Dyson sphere. And here's the beautiful part. A Dyson sphere would leave a fingerprint we could actually detect. All those structures soaking up starlight would heat up, and they'd have to radiate that heat back out as infrared. So from a distance, the star would look strange. Dimmer than it should be in visible light, but glowing far too brightly in the infrared. A star wearing a warm coat. In 2024, a project out of Sweden called Hephaestus went looking for exactly that fingerprint. They took data on roughly 5 million stars, cross-referenced 3 separate sky surveys, and built a filter specifically designed to throw out every natural explanation they could think of. Dust, background galaxies, instrument errors. All of it filtered away. 7 stars survived. 7 red dwarfs, all showing an infrared excess that matched, uncomfortably well, what a partial Dyson sphere would produce. Not proof. Nobody serious called it proof. But 7 objects that made it through a gauntlet built to eliminate them. Now, the honest counterweight, because this channel doesn't do you the disservice of skipping it. Follow-up studies have argued that the most likely explanation isn't a megastructure at all. It's contamination. The leading suspect is something called a hot dust-obscured galaxy, a distant, dust-shrouded galaxy blazing in the infrared that happens to line up almost perfectly behind each of these stars from our point of view. In other words, a cosmic photobomb. But stop and appreciate that even the boring explanation is spectacular. To explain away all 7, you have to invoke 7 separate galaxies, each hidden behind a star, each masquerading as alien engineering. The mundane answer is a stack of coincidences almost as strange as the thing it's replacing. And the candidates aren't fully closed out. They sit there in the catalog, 7 little red stars, glowing with a heat nobody has completely accounted for. Maybe it's dust. Maybe it's distant galaxies. Or maybe around one of those faint red suns, something is quietly drinking the starlight. We don't know yet. And not knowing in this case is the whole point. Number 2, the echo from the moon's distance. This one is old. Older than SETI. Older than the space age. Older than almost anything else we've talked about. And it's the reading that, more than any other, feels like something answered back. In the late 1920s, radio engineers in Norway and the Netherlands were experimenting with transmitting signals and listening for their return. Ordinary radio bounces off the upper atmosphere and comes back in a tiny fraction of a second. That's expected. That's physics. But every so often, they recorded something that made no sense. An echo of their own transmission would come back not instantly, but seconds later. 3 seconds. 8 seconds. Once, reportedly, up to 15. Delays far too long for any bounce off the sky. For decades, these long-delayed echoes just sat there, an unexplained curiosity in the engineering journals. And then, in 1973, a Scottish researcher named Duncan Lunan did something that turned a footnote into a legend. He took the list of delay times from those old 1920s experiments and plotted them out on a graph. Time along one axis. And what emerged, he claimed, looked like a map. Specifically, a star map of the constellation Boötis, with one star, Epsilon Boötis, sitting oddly out of place, as if marking where the sender came from. Lunan's suggestion was staggering. He proposed the echoes were coming from an alien probe, parked quietly in orbit near the moon, that had been waiting in our system for something like 13,000 years, patiently bouncing our own signals back at us, with a message hidden in the timing. And here's the detail that keeps it from being easy to dismiss. Those echoes were reportedly too strong to be simple passive reflections. A dead rock doesn't amplify what hits it. Something out there, at roughly the distance of the moon, seemed to be taking our signal and sending it back with force. Now the truth. Lunan himself later backed away from the star map. Physicists have real, natural candidates for long-delayed echoes, resonances in the plasma around our planet, signals ducting through the magnetosphere in strange loops. The pattern was almost certainly our own minds doing what they do best, finding a face in the noise. Almost certainly, but not entirely. The echoes themselves are real. They were recorded by serious people, and they have never been perfectly explained. And on a quiet night, it is very hard not to imagine a machine, older than every human city, sitting out near the moon, waiting and answering. Number 1. Little Green Men. In the summer of 1967, a Cambridge graduate student named Jocelyn Bell was staring at paper, miles of it. Her radio telescope printed its data as ink squiggles on long rolls of chart paper, and it was her job to read them by hand, hundreds of feet a day. She was looking for quasars. What she found instead was a little bit of scruff. A small, repeating smudge she couldn't explain and couldn't ignore. So she looked harder. And what came out was almost impossible to believe. The signal was pulsing with a regularity that was, frankly, terrifying in its precision. A pulse every 1.33 seconds. Over and over, steady as a metronome, sharper than anything a natural object was supposed to produce. Nature, as far as anyone knew, did not tick like a clock. The team, half joking and half not, gave the source a name, LGM-1. It stood for Little Green Men, because they genuinely had to put it on the table. What kind of thing broadcasts a signal that regular, that deliberate, that clean? For a few weeks in Cambridge, some of the sharpest minds in astronomy sat with the real possibility that a young woman reading chart paper had just stumbled onto a beacon from another civilization. Bell herself later admitted she was almost annoyed by it. She was trying to finish a thesis, and here was the possibility that aliens might get in the way. But she didn't celebrate and she didn't panic. She kept looking, and then she found a second one. A different part of the sky, a separate source, ticking with the same impossible regularity. And that changed everything. 2 alien civilizations on opposite sides of the sky would not independently start broadcasting the same metronomic signal at us at the same time. If it was happening in 2 places, it wasn't a message. It was physics. Nature. Doing something we had never seen. What she had found was the first pulsar. A neutron star, the collapsed core of a dead sun, packing more mass than our sun into a ball the size of a city, spinning so fast it swept a beam of radio across the Earth once every rotation. A cosmic lighthouse, a class of object nobody knew existed. And that is the strange, quiet lesson underneath every reading on this list. Again and again, we point our instruments at the dark, and something answers in a language that looks exactly like intelligence. A rhythm, a pattern, a signal too perfect to be an accident. And every time we've chased it all the way down, the universe has handed us something stranger than aliens. Not a civilization, but a new kind of star. Not a message, but a new law of nature. Maybe one day the scruff on the paper really will be someone saying hello. But until then, every time we ask the universe if anyone is there, it answers by showing us it is far stranger than we ever imagined. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.